Hi, Assalamualaikum and good day. Today you are going to learn on how to solve the definite integrals. Following is the objective of today's lesson. Hopefully, by the end of this session, you should be able to solve definite integrals of different types of function using basic rules of integration and using integration by substitution. A definite integral is an integral with the bounded limits in which a is the lower limit and b is the upper limit of the integration. Note that definite integral does not involve a constant of integration and it gives us a definite value or a number at the end of the calculation. In other words, with definite integral we can ignore the c. The definite integral of f(x) between x equal to a and x equal to b represents the area of region under the curve of f(x) bounded by the x-axis x equal to a to x equal to b. Following are the properties of definite integrals that you need to know. Refer to example 9. Solve the following definite integrals using the suitable properties. To solve a, bring the constant 3 outside the integral, given that the answer for the integral over the interval 2 to 8 is 3. Thus, 3 times 3 is equal to 9. As for b, when the same integral are added, in which the intervals are linked together, it can be combined as one, become the integral of f(x) over the interval 2 to 8, which is equal to 3. For c, as the lower limit is greater than the upper limit, rewrite the integral by interchanging both limits with a negative sign at the front. Then split the integral into 2, become negative, integrate f(x) with respect to x from 2 to 8, plus integrate 3 with respect to x from 2 to 8. Given that the answer for the first integral is 3. For the second integral, integrate 3 is 3x. By evaluating this integral over the interval 2, 8, the answer is 24 minus 6, which is equal to 18. Minus the two answers of the two integrals, you will obtain 15 as the final answer. Refer to D. The integral of f(x) dx plus k dx over the interval 2, 8 is equal to 20, given that the answer for the first integral is 3. For the second integral, integrate k is kx. By evaluating this integral over the interval 2, 8, the answer is 8k minus 2k, which is equal to 6k. Solving 6k equal to 17, you will get k equal to 17 over 6. Next, refer to example 10. Solve the following definite integrals. For a, by letting u equal to 2x minus 1 and differentiate, you will get du over dx equal to 2. Substitute this into the original integral and simplify, you will obtain 1 over 2 integrate u to the power of negative 2. Integrate with respect to u and replace the u back to 2x minus 1, you will get negative 1 over 2 multiply with 1 over 2x minus 1 plus c as the answer. By subtracting the answer of the integral at the upper limit with the integral at the lower limit, you will get negative 2 over 3 as the final answer. For b, by letting u equal to 2x and differentiate, you will get du over dx equal to 2. Substitute this into the original integral and simplify, you will obtain 1 over 2 integrate cos u. Integrate with respect to u and replace the u back to 2x, you will get 1 over 2 sine 2x plus c. Then substitute the interval into the answer and simplify. You will obtain 0 as the final answer. Take note that the interval for the trigonometric function is always in radian, so the calculator must be set to radian mode before you do the calculation. Refer to example 11. You need to find the value of k for the given integral. Given that the answer for the integral of fx over 3 dx from 0 to 3 is equal to 6, simplify this, you will obtain the answer for the integral of fx from 0 to 3 is equal to 18. Given that, for x less or equal to 1, the function is defined as x minus 2, and for x greater than 1, the function is defined as kx squared. Therefore, the integral of fx from 0 to 3 can be written as the integral of x minus 2 from 0 to 1 plus the integral of kx squared from 1 to 3. As the integral is equal to 18, solving for the k value, you will obtain k equal to 9 over 4 as the final answer. Refer to example 12. You need to evaluate the following integral. To solve, split the first integral into two, become integrate x with respect to x from 0 to 2, plus with 1 over 3, integrate fx with respect to x from 0 to 2. Then, split the second integral into two, become integrate fx with respect to x from negative 1 to 2, minus integrate fx with respect to x from 0 to 2. Solving the integral of x with respect to x over the interval 0, 2, it is equal to 4 over 2, which is 2. Then substitute the answer for the given integral accordingly and simplify. You will obtain 25 over 3 as the final answer. In order to check your understanding on today's lesson, please do the following exercise. In the next lesson, you are going to learn about the mean value theorem for integral and the fundamental theorem of calculus.